Okay, good day, everybody. My name is Ashish Kudesia, and I'm also joined by my colleague Soumya Rai. We're part of the digital organization in AI solutions at EXL, and we're here to talk to you about the insurance LLM. So, just to get started, to start really with what is EXL's overall focus in generative AI agents, and large language models. EXL specifically is playing in the space of, as you see on the screen on the left part, starting with domain based data engineering for the purpose of building large language models and domain fine tuned models. We do a lot of work in just making sure that the data is correct, it has the right integrity, it is in the right formats, etc., for the purpose of building out domain large language models, AI agents, etc. EXL does not play in the space of foundational models. There is a lot of hectic activity there with almost everybody, with almost very large players actually coming up with new and improved versions almost on a weekly basis. EXL does not play in that space. We are very keen consumers of all the activity that happens there. So we monitor that space very regularly. And we continue to use the most relevant, most advanced models for very specific use cases of domain fine-tuning that we require to do, and also powering AI agents in that space. All of this is then actually used into infusing the inferences from our domain fine-tuned large language models and AI agents back into operations. And that is carefully done through a workflow orchestration, which plows back the inferences of all of that right into operations. That really is a strategic view on EXL's focus. What we've done over a period of time is we've launched the EXL Insurance LLM last year, which specializes in actually working for the purpose of claims medical records, and it helps accelerate claim adjudication by our deep understanding of data, domain, and AI. So EXL has a lot of access to privately tagged, labeled data, where we also have access by virtue of rights of data usage with specific clients. So we use a lot of client data with their acknowledgement and their permission, and after de-identification for the purpose of fine-tuning our foundational models and literally domain fine-tuning them. We use this also in the context of a lot of domain. We understand the claims processes, underwriting processes very well. We understand how the process flows through, how the data flows through different systems, what are the happy parts, what are the exception parts, etc. And through our ability of AI to be able to architect this solution using the data domain and to be able to architect the right solution on the cloud infrastructure using, and so this is essentially done currently on the AWS infrastructure with NVIDIA components, with the NEMO framework and the names and others, which we'll also speak to in subsequent pages. So this really was a capability that could have not been done without any of them missing. So we really had to bring together our deep understanding of the business, coupled with a deep understanding of the data and how the data is actually going to be fine-tuned and trained, and then of course how it will be inferenced. And it had to be very carefully architected using the AWS and NVIDIA components together. Going on, just to give you an overall glimpse of what the insurance LLM does, and just to explain at a high level, this offering specifically helps in insurance claims in any insurance LOB where there are medical records being generated. That typically happens in the insurance business in areas like workers' compensation, general liability, auto bodily injury, where anybody, because of an event, gets injured, goes to the hospital, gets their treatment, and there are a lot of medical bills and medical records, etc., get generated. All of these medical records then come to the insurance company because a claimant will actually make a claim to the insurance company that I need to be reimbursed for this work. So in the current state, all of these medical records come at the desk of a medical doctor. And a medical doctor will actually have to go through all of these records, and some of these run between 800 to 1000 pages. So they have to manually read all of these medical records, connect all the dots about all possible information, and very material information can be hidden away, let's say in page 786, something could be written in page 342. And so it is important that this information is very carefully read, in not just for courtesy to the claimant who's actually injured, but also in a court of law, because if a medical doctor or a claimant just missed this information, then this can be a contestable claim in the court of law. So all of this is currently done manually. They have to, as you see on the left of the screen, they have to deal with a lot of variety of unstructured and structured data. We claim medical records. They have to go through procedure manuals within which this has to be adjudicated. They have to consider a lot of medical ontologies as they go through preparing this. So all of this is significantly very, very manual. So what we've done now is we've now used supervised fine tuning. We've actually prepared question answer pairs. We've prepared input output pairs. So of for the purpose of fine tuning. So in terms of inputs, we've taken, let's say, a combination of these medical records. So let's say 1,000 pages of medical records are then condensed by a medical doctor into 4 pages of an overall summary. So we've taken that as a pair. So 1,000:4 is one pair and 1,000:4 another pair. With like this, we've taken 14,000 closed claims and used this as our training corpus for the purpose of supervised fine tuning. And using this training corpus, we have then fine-tuned our foundational model with a lot of obviously data pre-processing, data de-identification. Data de-identification is very important because this was privately labeled client data. But of course, for de-identification, we are guided by HIPAA Safe Harbor. HIPAA Safe Harbor very clearly articulates 18 principles or 18 attributes and entities that need to be de-identified. So we've done that for the purpose of fine-tuning, actually before fine-tuning, and then use supervised fine-tuning on those combinations of 1,000 pages and 4 condensed summaries. So that's for the summary task, but also for question answering capability. So you will have claim adjusters and medical doctors interrogate and sort of inquire about the claim in the interface. So that actually just happens like prompting a question and expecting an answer about the claim. So that is done through training again of question answer pairs. We've prepared a lot of questions and answers from a ground truth perspective, which a medical doctor has then helped curate that training data set. So we've had one core data set, and then we've also created multiple variations of that using, again, large language models to be able to prepare a larger training data set for the purpose of question answer pairs creation as well. So as part of this, then what the LLM can now do is it replaces the way the medical doctor is manually doing adjudication, reading all of this information, gathering a lot of facts from various spaces, connecting the dots, triangulating a lot of data, does all of that reasoning together itself, and then prepares in a scientific manner the essence of those claims. So it essentially takes out tags, which really are the essence of our claim. And then using those tags, a certain combination of those tags prepares these summary headers and it prepares these summaries. So that really is what the LLM eventually does. And like I mentioned, that all of this has been infused back into operations. So we very clearly articulate who are the user personas in terms of using the inferences of the LLM. And we've got colleagues like claims staff as adjusters, clinical staff, doctors, qualified medical resources. Several times we see these claims are litigated or contested. And so we also have legal staff who use the outputs of these summarized claims as well. And just in terms of the measurement and benchmarking, we compared the measurement and benchmarking of the question answering and the summarization tasks with different foundational models as well. So these are general purpose models. So just so we know, the EXL insurance LLM is fine-tuned on the Llama 8 billion foundational model. And we fine-tuned it like that. We've compared and benchmarked this against the same sort of lightweight category. We think this is a lightweight LLM, and compared it not just in the same lightweight category, but also in the much heavier weight category. So the 70 billion model, GPT-4 or Gemini 1.5 is like a 1.5 trillion parameter model. And all in all, our accuracy was better by all other models, at least by a margin of 30%. And that was always our hypothesis, that we actually, once you fine tune a model to be able to excel in a very specifically trained set of tasks, it will have better inferencing, better reasoning results than foundational models would do. And just to explain how we've actually done this, while I've given you an overall aggregation of scores and comparisons, the way we've actually done this is, just to be fair to all LLMs, we actually served the same synthetic data for evaluation to all LLMs. We served and posed exactly the same question to all of them. And we also took out the ground truth from our medical doctors on what would they expect the answer for that question to be given a particular claim. That was the fair chance given to all LLMs. And so we got the response from the EXL LLM, which was actually very concise. It covered all the material required details. But in several other LLMs, the responses were very verbose, very descriptive. They actually missed required information, and in some cases also added extra information that was not asked in the context of the question. So I will not classify this as hallucinations. It's not that they are making up, definitely not. But that information is somewhere in the claim. So, for instance, this context was about question was about what are the inconsistencies in the patient statement with respect to a claim. This is not a very straight fact finding question. It's a difficult reasoning question for an LLM to be able to answer. And so this LLM, at least the other one, started giving information, extra information about airbag damage, vehicle damage, windshield damage, etc., which is available in the claim, but it is not relevant to the question. So by virtue of then preparing a summary which gives extra or missing information, it defeats the purpose of preparing the condensed summary in the first place. So that's a brief about how we've prepared the LLM, what was the use case, how has been the evaluation and benchmarking. And with that, also briefly, just to share on how we've prepared the data in the readiness for the training. We had key data attributes, like I mentioned, we had privately labeled tagged data. We had worked with 12 plus years of training corpus data with the 1000 is to 4 and the question answer combinations. We worked with 14,000 closed claims as the corpus of data, which was equivalent to about 2 billion tokens. This was in a combination of both structured and unstructured data, which went through a lot of data curation, aggregation, categorization of tags, and then evaluation, like I spoke, with different LLMs. Of course, there's a lot of data curation that happened in terms of extraction, data structuring, cleaning, etc., within the overall security considerations that were driven by HIPAA Safe Harbor, and of course, additional algorithms and post-processing to make sure it was within security considerations.
I'm excited to share how EXL, in partnership with NVIDIA and AWS, is building a purpose-built insurance LLM designed to be enterprise-grade, optimized to perform, and grounded in responsible AI practices. What we see here is the end-to-end AI development pipeline that powers our EXL LLM. We have broken down into the 4 phases, which is data curation and de-identification, containerization and the fine-tuning, and optimization, and finally the inferencing. Now, each step is powered by the purpose-built tools from NVIDIA and AWS. Just like in any of the LLM projects, the high quality of data is extremely important. So we start with the de-identification and curation using the NVIDIA's NeMo Curator and Rapids for the fast GPU accelerated data pipelines. AWS contributes Amazon Comprehend for the NLP and S3 for the storage, secure and scalable storage. So this ensures we protect the sensitive data and meet the compliances needs from the start. Next is the containerization, where we scale securely and efficiently. NVIDIA NIM containers, Helm charts, and NGC registry allow us to manage the model components with agility. AWS EKS and the Lambda allow us to orchestrate these containers and build a responsive, event-driven architecture that are cloud-native. This phase is where the generic LLM is transformed into an insurance expert. We use NVIDIA NeMo integration with MLflow, and it's customized a module to fine-tune the model with the real-world data. As Ashish spoke about, we have been using 12 years historical data for our claims processing. Inference is where the model meets with the actual end users. Whether it's a chatbot, email assistant, or the claims processor, we deploy the model using the NVIDIA NIM, optimized with TensorRT and served through the Triton inference server. NeMo guardrails ensure the responsible outputs, while the NeMo evaluator tracks the accuracy and the drift, which is extremely important in a scalable and enterprise-wide solution. AWS SageMaker and EKS supports the seamless production deployment. All of this runs with the NVIDIA AI license, enterprise license, and the NeMo framework, giving us the powerful LLM building blocks, optimized GPU utilization, and the secure deployment for the standard enterprise use. So by combining the domain knowledge of EXL, accelerated computing from NVIDIA, and cloud infrastructure from AWS, we have built the foundation for delivering the tailored generative AI use cases across the insurance value chain. From underwriting to the claims to the customer engagements, this is more than a model. It's a full stack solution that is enterprise ready, responsible, and industry aligned. Having said that, I would like to shift our attention to one of the platforms on which the overall solutions of the workflow is running. So EXL has actually developed an Accelerate.ai, the Accelerate.ai platform, which our enterprise framework designed to unlock the full potential for the agentic AI across the business life cycles. This framework ensures the AI values delivery from the ideation to all the way to production. At the core of the agentic solution, the domain specific and the task specific AI agents designed to deliver the targeted outcomes. Now, these agents are automate design decision making, drive the operational efficiency, and enhance the customer experience by deeply integrating with the enterprise-wide workflows or the systems or the multiple databases. Now, Xray.ai, which is our platform, is a cloud agnostic that is both flexible and modular. It supports everything from the data preparation, as we saw in the previous architecture, to the model training, from the agentic app development to the scalable production hosting. And all is based on utilizing the NVIDIA services across the multiple hyperscalers such as AWS, GCP, and Azure. Now, to fast track our solution delivery, we bring over 100 accelerators spanning infrastructures, data models, pre-built apps, and the MLOps template. These accelerators drastically reduce the time to value while ensuring the consistency and the scalability in the agentic AI deployments. So when we combine the agentic solutions with the enterprise grade platform capabilities, accelerators, and talent, we get a full stack framework to deliver the business impact. Accelerate.ai empowers the domain specific AI agents to dynamically interact with the enterprise systems, streamline the process, and ultimately enhance the decision making and the customer experience. Now, at the core of any of the platform, and when we talk about the scalability of the solution, the observability holds a very, very important role. So monitoring and the governance are the essential as the AI agents or any of the generative AI solutions moves into the production. That is where our platform steps into one-stop cockpit for managing and monitoring the agentic AI solution across the various life cycle. So the AI Ops cockpit is a central hub for the observability. It is designed to install across our entire AI ML pipelines and provides a real-time 360-degree view of our AI asset from development to deployment to post-production performance. Because scaling in understanding the behavior and the performance of our solution post-production essentially is a key to for the successful delivery of any of the generative AI or the AI specific solutions. In the development phase, it tracks the code commits, monitor version control sets, capture the development activities. This ensures the early stage transparency and helps teams catch issues before they become even a blockers, such as hard coding the passwords or hard coding any of the dates. These are very common examples where we see a blockers having when we go ahead for the deployment, etc. So having solutions in place during the development phase actually helps the developer in eliminating such issues, which can actually lead up to the governance or any of the data leakage issues in future. In the deployment phase, the cockpit tracks our pipeline, monitor the infrastructure health and the security compliance, and resource utilization. Both IT and data scientist teams the tools to deploy safely and efficiently. Now, the post-production, so once the AI solutions or the AI agents are in the production, the cockpit shifts the focus to the post-production. It analyzes the user activity, track the model performance over time, and flag any potential drifts or anomalies before they impact the business operations. Now, this holds the key in a successful adoption of the solution. Now, for example, if the solution built on the insurance LLM, if we see that the adoption or the utilization of the application not so well being utilized by the end users, or the number of the users on the applications are pretty low, it will help me in understanding the actual blockers. It will help me in understanding where exactly are the issues and why it is not being well adapted on ground. Because for any successful AI solution, no matter how well it has been architected or designed or technically savvy, it is very, very important to have a very strong change management pipeline and a very, very strong adaptation pipeline. So in order for the application to be well utilized, it is also important for us to monitor how well the performance of the applications are being done in production. So that is why the post-production monitoring is extremely important. So with Accelerate.ai observability, we are just not building the AI, we are operationalizing it with trust, transparency, and accountability. Now, this capability ensures our AI, generative AI, and or the agentic AI solutions are continuously optimized, secure, and aligned with the enterprise outcomes. And this is one of the this is one of the approach that we basically take in terms of in how do we really evaluate and how do we understand at what stage are we in part of the observability part. So whether we do an assessment, and that basically includes a tool such as Jira or Asana, etc. And that helps in identifying where are the blockers, at what phase of the development cycle or the SDLC cycle we have a blocker, and accordingly we suggest the remediations, or accordingly we suggest the pipelines that should be deployed in order to have those blockers being eliminated. So that is how we basically move from the assessments to actual deployment of, or the observability deployment of the pipelines across the entire value chain of the deployment cycle, or the development to deployment cycle. That's all I have for today, and thank you all for joining.